Hey everyone, this is Mr. Garcia, and this lesson will cover 3D figures and cross sections. So let's go over a few definitions first, and then we'll get into examples for each one of these figures. So a polyhedron is a three-dimensional figure whose surfaces are polygons. Okay, a prism is a three-dimensional figure with two parallel and congruent polygonal bases. It is named by the shape of the base, and the sides are all rectangles. So let's go over a few examples for rectangular prisms. Rectangular prism, the bases are rectangles, and in this case, I'm just pointing to the faces here. Okay, so this is one face of the rectangle, and I know it. I mean, of this rectangular prism, and I know it's hard to tell. So I'm going to show you an example here. This is a rectangular prism, and prism. When I say faces, I mean the surfaces you can touch. Okay. So these are the faces of this rectangular prism. And you should also be able to count them. The next one is the triangular prism. The bases are triangles. And for this one, I'm going to refer to the edges. So edges are all these places that I'm touching here. So this is an edge, another edge here. And you should also be able to count the edges and the faces of any prism. Okay. And the next one is a hexagonal prism. Okay, the bases are hexagons, and for this one I'm going to point to the vertices. And as you can see, the vertices, I'm referring to the sharp corners here. So this is one vertex, another vertex here. So this one has 6 vertices on one base, and if you flip it over, it also has 6 vertices on the other base. Okay, now let's continue on to, well, let's go over the next few. I'm just going to mention these. Okay. The cylinder, the cone, the sphere are also three-dimensional figures. So there you have the cylinder, the cone, and the sphere. And we'll get into those later on. Okay. A net is a 2D diagram that can be folded to form a 3D figure. So here we are being asked to draw a net for each three-dimensional figure. And as you can see, this 3D figure, this is a prism, right? Because it has 2 bases. So this is the sides of the bases it has 5 sides, so this is a pentagonal prism here. If you were to cut this into a net, since the bases are pentagons, this is one base, this is the other base, and as you can see, the sides are all rectangles. So if it has 5 sides, then that means it's going to have 5 faces. So this is one rectangle, 2, 3, 4, 5. So if you were to create a net of this pentagonal prism, it will look like this here. Okay, the next one is a pyramid. Okay, so this is a pyramid, and if you do a cross section of this pyramid, it will look something like this. So you have this triangle, this is the base, and if you fold this triangle here, and this one, you'll get this pyramid back. Okay, so there are examples on how to create nets out of 3D figures. And the next section is a cross section. So a cross section is the intersection of a solid and a plane that slices through the solid. So imagine it's like when you're dicing tomatoes or cucumbers or any other vegetable that you have cut before. So this is what it's like, okay? So here it's asking for a description of each cross section. So if I do a cross section of this cone and a plane, okay, when they cross, when the crossing happens, I end up with a circle. So the cross section of a cone and a plane is a circle because, and in this case it is a circle, but imagine if I do a cross section with the plane, but instead of horizontal to the base, I do it, perpendicular to the base, which is the circle, then we'll be looking at a triangle. So the point is, look at the way the cross section is being done. Okay, since it's parallel to the base, then this should be a circle. The next one is this has 1, 2, 3, 4, 5, 6 sides, so that means a hexagon. If I do a cross section parallel to the base, I should also get a hexagon. But what happens if I do a cross section perpendicular to the base? What is that going to look like? Okay, and I hope you guessed that it will be a triangle. So again, it depends on how you do the cross section. This one is parallel to the base, so it has to be the same shape of the base. The next one is a cross section of a rectangular prism. Okay, so if you do a cross section of a rectangular prism, as you know, this is well, actually, no, this is not a rectangle. This looks like a square, but you know, a square is a rectangle. So I would add also a square here. Okay, so either one of them it's fine, but I think this is a square. But if you say a rectangle, that I don't think that's incorrect, because a rectangle, a square is also a rectangle. So I'll just do parentheses here. Okay. Let's go to the last section of the lesson. The last section is asking us to identify. Okay, and I know you already saw the answer, so let me erase it real quick. Okay, so let's see now. All right, just erase it so that, and then I know you guys already see it. Okay, so this section says identify the 3D object generated by rotating a 2D shape. So rotate a rectangle around a line that runs along one side of the rectangle. So imagine that you have, this is a pen, right? And you attach or glue a sticky note to that pen. And imagine that you do this. You're rotating the pen fast. The question is, what shape is that going to form? So to visualize this, okay, you rotate the rectangle around the line. And as you can see, as you rotate it, okay, this goes fast, and if you look at this from, let's say, from the top perspective, okay, I'm rotating this, to you it's going to look like a cylinder, right? So that's all this is. If you rotate, imagine if you do a triangle. Can you imagine what that rotation will look like if you rotate here instead of a rectangle? Imagine you do a right triangle, right? So just do this, something like that. What is that going to look like? And if you guess the cone, you're correct. Okay, I'll see you or talk to you in the next lesson. Bye-bye.